The ground beneath you feels solid, stable, unmoving. It feels like the one thing in your life that isn't going anywhere. The earth seems fixed, anchored, dependable. When you stand up, you're not bracing for motion. When you sit down, you don't feel speed. Everything about your experience tells you that this planet is steady, and yet that feeling is completely wrong. The earth is not still. It is not resting. It is not anchored to anything. At this very moment, the planet beneath your feet is moving through space at roughly 67,000 miles per hour around the sun. It is spinning at over 1,000 miles per hour at the equator. And more strangely than all of that, it is constantly falling. Not metaphorically, literally. The earth is in continuous freefall. That sounds impossible, because falling implies something beneath you. When you drop a glass, it falls toward the floor. When you trip, you fall toward the ground. Falling has direction. It has a destination. It ends in impact. But the earth never hits anything. It doesn't crash into the sun. It doesn't plunge into some cosmic abyss. It just keeps going. Around and around, year after year, century after century, in what looks like a calm, predictable orbit. So which is it? Is the earth stable, or is it falling? The unsettling answer is that stability itself may be an illusion created by motion. You don't feel the earth racing through space because everything around you is moving with it. The air moves with it, the oceans move with it, you move with it. There's no wind of 67,000 miles per hour tearing past your face because you are part of the system in motion. Relative to your surroundings, you appear still, but relative to the sun, you are in a perpetual plunge. Pause for a second and let that land. The same gravity that pulls a dropped coin toward the ground is pulling the entire earth toward the sun right now. The same force that makes you fall is acting on a planetary scale. The difference is not in the force, it's in the motion. Somehow the earth is falling toward the sun without ever reaching it. That is not a poetic statement. It is a mechanical one. And if you truly understand it, the way you think about motion, gravity, and stability will shift permanently. Because the question is no longer whether the earth is falling. The question is what falling actually means. When you hear the word falling, you picture something simple. A dropped phone, a slipping ladder, a body pulled downward by gravity until it collides with the ground. Falling, in everyday language, means losing support. It means moving straight down towards something solid. It means impact. But physics does not care about everyday language. In physics, falling has nothing to do with down in the way you instinctively imagine it. Falling simply means accelerating under the influence of gravity. That's it. No requirement for crashing. No requirement for a surface waiting below. And this is where the confusion begins. Because if falling just means accelerating toward a massive object, then the Earth is absolutely falling toward the sun. The sun's gravity pulls on our planet constantly. There is no moment when that pull switches off. No pause, no break. The Earth is being drawn inward every second of every day. So why doesn't it spiral straight in? The common answer is balance. People say the Earth is balanced between gravity and motion as if two forces are canceling each other out. That explanation sounds comforting. It suggests stability. It suggests a kind of cosmic equilibrium. But that's not what's happening. There is no balancing force pushing the Earth outward to counter gravity. There is only gravity pulling inward and the Earth's forward motion carrying it sideways. Nothing is canceling gravity. The planet is not resisting the sun's pull. It is responding to it completely. To understand this, you have to let go of the idea that falling must be vertical. Imagine standing on a very high mountain and throwing a ball forward. It travels in an arc and eventually hits the ground. Throw it harder, and it travels farther before landing. Throw it even harder, and it goes farther still. Each time gravity pulls it downward, but its forward speed carries it outward before it touches the surface. Now imagine throwing it so fast that as it falls toward the Earth, the surface curves away beneath it at exactly the same rate. The ball keeps falling, but the ground keeps dropping away. It never lands. That is orbit. The object is not suspended. It is not floating. It is not defying gravity. It is falling continuously while missing the ground. This is the key shift. Falling does not require an ending. It requires acceleration towards something massive. And if sideways motion is fast enough, the fall can continue indefinitely. Stop for a moment and reconsider the Earth. The sun's gravity pulls the Earth inward. At the same time, the Earth is moving sideways at enormous speed. As it falls toward the sun, its forward motion carries it along a curved path. The sun's gravity bends that path into a circle, or more precisely, an ellipse. The Earth is not hovering around the sun like a bead on a wire. It is constantly trying to move in a straight line, while gravity continuously curves that line inward. The result is a closed loop. This means something subtle but profound. If the Earth suddenly stopped moving forward, it would fall directly into the sun. If gravity suddenly vanished, the Earth would shoot off into space in a straight line. Orbit exists only because both are happening at once, inward acceleration and sideways motion, so the Earth is falling completely, fully, obediently. It just never reaches the destination. And once you accept that, the real revelation begins to emerge, because orbit is not a special condition. It is not an exception to gravity, it is gravity in action, which means the Earth's path around the sun is not a stable compromise. It is a perpetual freefall that never ends. Now we arrive at the point where the intuition finally gives way. Orbit is not suspension, it is not balance, it is not a delicate truce between opposing forces. Orbit is falling sideways. That phrase sounds almost too simple, but inside it is the entire mechanism of planetary motion. To see it clearly, imagine something even more extreme than a mountain. Imagine a cannon placed on a very high cliff overlooking a perfectly smooth Earth with no air resistance. You load a cannonball and fire it horizontally. It travels forward, gravity pulls it downward, and eventually it strikes the surface. Fire it harder. It travels farther before landing. Harder still, farther again. Each time, the cannonball falls toward the Earth. Gravity never stops acting on it. The only thing changing is how fast it moves forward. Now imagine increasing the speed so much that as the cannonball falls, the surface of the Earth curves away beneath it. The Earth is round. That means the ground is constantly dropping away from a straight path. If the cannonball's forward speed is high enough, the rate at which it falls matches the rate at which the Earth curves downward. The cannonball keeps falling, but it never hits, it circles the planet. That is orbit. Not a special state, not a suspension, just a perfectly tuned fall. And this is exactly what the Earth is doing around the sun. The Earth is the cannonball. The sun is the massive body pulling inward. The forward motion of the Earth is what keeps it from plunging straight in. Gravity bends the path inward continuously. The Earth tries to move in a straight line, as all objects do. Gravity refuses to allow it. The compromise between straight line motion and inward pull produces a curved path. That curved path closes in on itself. This is not balance in the way you might imagine two forces canceling out. Nothing is canceling gravity. The Earth is accelerating toward the sun every second. Its direction is constantly changing because of that pull, but its speed forward is high enough that the fall becomes a curve instead of a collision. Pause and consider how radical that is. Every year when the Earth completes one orbit, it has fallen toward the sun for 12 straight months. It has been pulled inward the entire time, yet it never arrives. There is no moment when gravity pauses, no moment when the Earth is coasting freely without influence. The curvature of its path is evidence of constant inward acceleration, and this applies to everything in orbit. The moon is falling toward the Earth right now. If it were not moving sideways fast enough, it would crash into us. Satellites orbiting the planet are not floating. They are in continuous freefall. Astronauts inside the International Space Station feel weightless. Not because gravity is gone, but because they are falling around the Earth instead of straight down into it. Weightlessness is not the absence of gravity. It is the experience of falling with nothing to stop you. This changes the picture completely. We tend to imagine the solar system as something orderly and calm, planets gracefully circling the sun in stable loops. But what is really happening is more dynamic. Every planet is in a state of controlled descent. Every orbit is a continuous attempt to move straight, continuously bent by gravity. And gravity itself is not a rope pulling inward from a distance. It is not a hook dragging planets through space. According to Einstein, gravity is the curvature of space-time itself. Massive objects like the sun warp the geometry around them. Planets move along those curves the way a marble rolls along a stretched surface. The Earth is not being pulled like a fish on a line, which is following the shape of space-time. Which means orbit is not resistance to gravity, it is surrender to it, complete obedience to the geometry of the universe. Let that sink in. The Earth does not defy the sun's gravity, it yields to it perfectly. Its sideways speed is not fighting gravity, it is what allows the fall to become a circle. And suddenly stability looks different. What feels like steady repetition, seasons cycling, years passing, is actually the result of relentless motion. The Earth is never resting. It is never static. It is perpetually accelerating towards something it will never reach. If its speed were slightly slower, it would spiral inward. Slightly faster, it would drift away. The orbit exists because of precise motion within curved spacetime. This is the reveal. Orbit is free fall extended sideways across a curved universe. There is no cosmic support beam holding the Earth up, no invisible rail keeping it on track, just motion and gravity interacting in exact proportion. And once you understand that, the implications widen. Because if orbit is falling, and the moon is falling, and satellites are falling, then falling is not an accident or a failure of support. It is the natural state of motion in the gravitational universe, which means the Earth is not uniquely unstable, it is simply obeying the same rule as everything else. And that brings the realization closer to home. Because if the planet beneath your feet is falling endlessly through space, then the sense of being firmly planted on something solid may not be what you think it is. If the Earth is falling, then so are you. That statement sounds dramatic, but it is mechanically precise. You are not standing on something that is stable in the way your senses suggest. You are standing on a planet that is accelerating toward the sun while spinning on its axis and moving through curved space-time. The only reason you feel still is because you are falling along with it. Stability, in this context, is shared motion. Think about what happens inside an elevator when the cable snaps. For a brief moment before impact, everything inside the elevator falls together. The people, the air, the loose objects. Relative to each other, they appear weightless. They float. Gravity has not vanished. In fact, it is acting fully. But because everything is accelerating at the same rate, there is no pressure force pushing upward. Now extend that idea to orbit. The Earth is in free fall around the sun. The moon is in free fall around the Earth. You are in free fall with the planet. The reason you do not feel like you are plunging through space is that everything around you shares the same acceleration. Stop for a second and reconsider what standing still actually means. When you stand on the ground, you feel weight because the Earth's surface pushes up against you, preventing you from falling toward its center. That upward push is what your body interprets as weight. But in orbit around the sun, there is no surface pushing back against the Earth's motion toward the sun. The entire planet accelerates together. There is no resistance force to create a sensation. You are not supported against the sun's gravity. You are falling around it. And that reveals something deeper about gravity itself. According to Einstein, gravity is not a traditional force pulling objects inward. It is the curvature of space-time. Massive objects bend the geometry around them, and smaller objects move along those curves. The Earth follows the curve created by the sun. You follow the curve created by the Earth. You are not being yanked downward by an invisible string. You are moving along the natural path carved into space-time by mass. This reframes falling entirely. Falling is not a failure of support. It is the most natural motion available in a gravitational field. What feels like rest is actually deviation. When you stand on the ground, the surface prevents you from following the curved path inward. The ground pushes back. That push creates the sensation of weight. But in orbit, nothing pushes back. The Earth is allowed to follow its natural path freely, which means the sensation of stability you experience daily is local and temporary. It depends on surfaces resisting gravity. On cosmic scales, there is no resistance. There is only motion along curves. You are part of a system in motion, so vast that your senses cannot register it. The air, the oceans, the continents, your own body, all accelerating together through space. Security, in this sense, is not stillness. It is coordinated falling. And that realization shifts something subtle inside your perception. The world no longer feels like a platform suspended in space. It feels like a trajectory, a path, a continuous descent that never ends because sideways motion transforms collapse into orbit. The ground beneath you is not a foundation anchored to the universe. It is part of an elegant, uninterrupted fall, which leads to a final reframing. If falling is not instability, but obedience to cosmic geometry, then perhaps what we call stability has never meant what we thought it did. We tend to associate falling with danger, loss of control, collapse, failure. But the Earth's endless descent around the sun tells a different story. Falling, in the deepest physical sense, is not catastrophe. It is alignment with gravity. It is motion shaped by curvature. It is the most honest response to the structure of the universe. The planet beneath your feet is not defying gravity. It is obeying it perfectly. Every second of every day it accelerates inward while moving forward, tracing a path that is neither straight nor plunging, but beautifully curved. What feels stable is actually dynamic. What feels fixed is actually in motion. And that reframes more than astronomy. It reframes how you think about certainty itself. Stability, at least in a gravitational universe, does not mean stillness. It means consistent motion within a larger system. The Earth remains in orbit not because it is anchored, but because its motion fits precisely within the geometry carved by the Sun's mass. Remove that motion and it falls inward. Remove the gravity and it drifts away. Stability emerges from relationship, not resistance. Pause and consider how different that is from the picture most of us carry. We imagine the solar system as a quiet arrangement of spheres circling obediently in empty space. But what is actually happening is more dynamic, more elegant. Every planet is in continuous freefall. Every moon is perpetually descending. Even light bends as it passes massive objects, following the curves of space-time itself. Nothing is suspended. Everything is moving. And yet this motion does not produce chaos. It produces order, predictable cycles, seasons, years, the return of familiar constellations. The regularity you depend on is the visible expression of invisible curvature. The Earth is constantly falling and never hits anything, because its sideways motion transforms descent into orbit. That simple fact dissolves the illusion of cosmic stillness. You are not standing on a stationary platform in space. You are riding a trajectory through curved geometry carried by a planet in perfect surrender to gravity. Once you see that, stability stops, meaning immobility. It means understanding the motion you are already part of.